Okay, so you're watching this video because you're looking for ideas on how to build a soundproof recording space. I want to let you know right off the bat that we're not going to build something truly soundproof. What we're going to build is a sound reduction space. Big difference. True soundproofing is going to annihilate sound from outside of the space, and it's very costly. It's going to require an investment of thousands of dollars plus a high level of expertise. Sound reduction, on the other hand, is relatively inexpensive. We've got a budget of about $500 to work with. So if you're comfortable picking up a hammer and a saw and a drill, we can save quite a bit of the expense by doing the work ourselves. Okay, here we are inside the finished booth. So this took, evenings and weekends. It took me close to a month, I guess, to complete from the day that I started cutting 2x4s until I finished putting the paint on the walls. Cost about $500 to build, and it achieved exactly what I thought it was going to. As a matter of fact, a set of speakers just outside this window is blaring Pink Floyd. Inside here, it doesn't even register 60 decibels. So how do we go about constructing a professional quality vocal isolation booth with a budget of only $500? Well, for starters, we need to know a little bit about how sound works. How does sound travel through different types of material? Once we understand that, then we can start to put together a materials list, and then we can start to construct our actual booth. Most of the information that you're going to need I've already compiled for you. I've put it together on my website, marant.ca. Alright, so what we're going to do is laminate together a sheet of 1/2 inch OSB and a sheet of 1 inch or 3/4 inch styrofoam insulation. And we're going to use this stuff here. It's an acoustic sealant. It's usually used for vapor barriers, but it's also used for sound barrier too. So you have to make sure that the foam insulation that you use is compatible with the sealant, because you don't want the sealant to melt through the foam. So what we're going to do is take a sheet of foam and a sheet of OSB, stick them together, and with only a couple of screws, we're going to attach them to our wooden frame. And we only use a couple of screws because the sound vibrations can be transmitted through the screws into the wooden frame and then out into the room or back into the booth, which of course you don't want. So the fewer rigid connections you have, the more soundproof the booth is going to be. So I just used the sealant. I've got it all over my piece of OSB, which I cut to size, and I've got a sheet of foam right here, and we're just going to stick them together. Okay, so what we've got is, as you can see here, the green part is my OSB and the white foam is together. The reason we do that is because sound travels really well through materials that are of the same density, but if you can alter the density of the materials or the substrate, the sound will have a harder time passing through it. And we will also use the same acoustic sealant as well, and we're going to put a layer of it, a bead of it, all the way around our frame, our wooden frame, which is the wall. stuff is really messy, don't get it on yourself, and it tends to leave little threads of it everywhere, so beware. And as you might imagine, you have to be fairly precise with your placement. Good news is that it's not like glue. It doesn't really dry out, so you can reposition it over and over until you get it exactly right. I think we got it. So we can see now with just one of the two walls in place, we haven't put the door frame in either on the diagonal there, but with one of those two walls in place, it's starting to shape up. Now, through the magic of television, we've got our three sides framed up. The door is on the 45-degree angle to match the platform that we've already built. Now, without getting too complicated on the attachment of the angled door to the side wall, all I did was use some 3.5-inch long screws, and I came in along the side perpendicular to the door frame and went deep in on an angle to the side frame. And what we've got is a nice rigid connection of the door frame to the two side walls. And we've also framed in a small window, because when you're inside a booth that's about 4 feet by 3 feet, it can start to feel a bit claustrophobic, even with good lighting inside the booth. And we don't want the window too large, however, because a big window is going to allow a lot of sound to bleed through. Glass is a difficult thing to block sound with. So on the inside here, we can see the layer of styrofoam, the OSB on the outside, and it's laminated onto the 2x4. All right, well, as you can see, we're getting to the point where we're going to do the window now. Pretty essential part. I'll show you what I did for the glass. I tried to cut it myself. It didn't work out so well, so I hired the professionals. Went to an auto glass store. So the auto glass store, they cut a 1/4-inch piece of glass for me and cut it into two pieces. This is the window frame. It's going to be upright inside our booth, but you'll notice, and this is what I wanted to show you, that the panes of glass are on an angle. So we've got one pane of glass that will go in, parallel or perpendicular, depending on how you look at it, to the window frame. The other pane of glass is going to go in on an angle. So that's going to do two things. Number one is the angle is going to help reflect away some sound from outside of the booth to make it even more soundproof. And number two, a little bit of science behind this, and I may be wrong, but here's the theory. The wider angle at this end and the narrower angle at that end is going to change the properties of the sound wave as it transitions through one pane of glass, through the air in between the two, and then into the second pane of glass. So the idea is that any of the sound wave that is not reflected off is going to transition through, but because of the different depths, there may be a little bit of perhaps phase cancellation inside. So that waveform is going to be even more disrupted before it gets a chance to resonate the outer pane of glass and allow the sound wave to travel on through. So let's put this together now. I've already got it all geared up, and you will notice a nice shiny bead of clear caulking inside those grooves. All right, new name for the video: Making Mistakes with Glenn. No, it wasn't that big a mistake. All I did was I put too much caulking inside the grooves, and when I went to sandwich everything together, two things happened. Number one, the glass just wouldn't squeeze down through the caulking, and as I pushed it down, a lot of it began to ooze out. So I kind of had to take everything apart again and clean it up and put it back together. So we're in pretty good shape. So here's the finished window. Caulking job isn't too bad. It's pretty tidy all the way around, with one exception. Over here on this side, it got a little bit nasty when it oozed out. So I think what we're going to do, we'll actually let that caulking dry, because it'll be easier to clean up with just with a razor blade. So we'll let it dry, we'll clean up the caulking, and we'll re-caulk it, and I think it'll look pretty good. Alright, well, just in case you missed it here, before I put the drywall on this, I just wanted to show you what we actually have inside the wall. Really simple. I found it's an airtight outdoor switch box, but it works really well for soundproofing because it's got a neoprene gasket on the front, it's coated on neoprene on the back, and it'll stop, quite a bit of sound from leaking out through this location. So the wire that I used is a 16 gauge wire. Don't have to use 12 or 14 gauge as you would in a normal household installation, because we're going to use 12 volt lights, 12 volt LED lighting inside, very energy efficient and low voltage. Current draw is probably less than half an amp, so no concern with using a very light gauge wire for that. The other thing we did is, over here for our ventilation, you'll notice these 3 holes across the top. They ventilate inside, and that looks like my large intestine snakes its way down. It's going to go down to the bottom, where it's going to it's going to have some negative pressure. I'm going to use some computer fans inside a little box. The computer fans are going to pull air out, but we don't want the sound of the computer fans bleeding back into the booth. Sound doesn't like going around twists and turns. Sound is a very straight ahead kind of thing. So the whir of the computer fan won't travel back up through all these twists and turns in the tube, but the air will have no problem coming down through that. So that's for the negative air pressure, to pull the air back out of the booth and keep it cool. So I don't know if you can hear that or not. There's a little bit of a hum in behind it. That's the fans. That's the ventilation into the booth. So the warm air that's going to accumulate up high, it's going to get pulled out through this air vent here and exhausted back out into the rest of the space. The cooler air from down below gets pumped in to refill the space. And it works really well. It's just a little noisier than I thought it was going to be. So I won't be able to have the fans running while I'm doing a recording. But I will be able to have them on while I'm doing a bit of rehearsal, a couple of dry runs through my scripts. And, in between takes, I'll pop open the door and turn on the fan and, give the space a bit of a refresh. It'll be okay. So since this project was primarily DIY and on a pretty low budget, $500 for a soundproof booth is pretty good, we had to build our own door, and that presented some challenges. So the first thing you need to know about soundproof doors is that anywhere that air has a chance to leak in, that's also where sound leaks in. So creating an airtight seal around the perimeter of the door is essential. And not just a single airtight seal, but 2. The more the better. So what we did is we have 2 individual seals. There's an inner seal and an outer seal. I'm going to show you those right now. We have. So if we pop it open, you'll see here's the outer seal. And you see the way that we have this flange around the outside, that when it closes, you get that outer seal. So that's your first step. Now on the inside, the door itself, which is quite deep, slides in and meets this second seal all around the inside. So between the outer seal and the inner seal, we end up being not perfectly airtight, but airtight enough to stop most of the sound. and you can hear the air gushing out as we close the door. That wraps up the video. I do realize that I didn't document every single aspect of the construction process along the way, which is unfortunate because there were some things that I wanted to be able to show you. However, if you go to my website, marant.ca, what I've done for you is I have documented everything. I've given you some very detailed instructions on exactly how to do some of the things that weren't in the video. For instance, how to go about constructing the ventilation system and making it work properly, how to put together the 12-volt lighting system and the 12-volt fan system, how to build the window. You'll get to read a little bit about how to avoid some of the mistakes that I made in the video. So please jump over to my website, marant.ca, go through that list, and I invite you, if you have any questions at all, to contact me through that website, and I'd be more than happy to answer those questions for you. So again, thanks for watching, and I hope to hear from you. All the best.